Okay, so in this problem you have a mountain climber who is holding onto a rope and there's tension up along the rope, and then her legs are touching the ground, or sorry, the wall, and so there's this force between her legs and the wall, and then her weight, which always goes straight down. So there's these three vectors that we are going to use with Newton's second law to do the sum of the forces equals mass times acceleration. One of the first things you're going to need to do is go ahead and break this force vector into an x and y component using cosine and sine with the 15 degrees. For this tension vector, you're going to go ahead and figure out, oh, this angle up here is 31 because of the rules of parallel lines, which means that your tx, or your x component of the tension, is going to go with sine, and the ty will go with cosine. So now that we have our vector picture drawn, we'll see my work up here. So we start with the sum of the force in the x equals max. Well, f of x is pointing to the right, minus t sub x is to the left, equals 0 because there's no acceleration. So instead of f sub x, I'm going to plug in f cosine 15, add tx to the other side, and I'll write t sine 31. I'll leave this alone for right now because I have an equation with two unknowns. In the y direction, okay, sorry, I had to take a time out for my kiddos. So in the y direction, we have the sum of the forces in the y equals may. Fy and ty are both up, so they're positive vectors. The weight is straight down, so it's negative. Again, there's no motion in the y direction, so this is 0 again. So go ahead and get rid of our subscripts of y and instead write f sine 15 plus t cosine 31 equals mg. Now really we're done with the physics part, and this becomes an algebra problem, a simultaneous equation. So I isolate a variable over here, plug in over here, pull out my calculator. You know, sine 31 times sine 15 over cosine 15 is just a number. Cosine of 31 is just a number. Combine those, divide both sides, and you're going to get 522 newtons is the tension in the rope. Then take that tension here and plug in back over here, and you're going to get a force of 278 newtons. So this is, a good problem, because each time you solve one of these problems, you need to draw a free body diagram, figure out what's in the x direction, what's in the y direction, and then go ahead and apply Newton's second law. After that, it should be an algebra problem. Hope this helps.